Okay. So at the beginning of the year, the first activity that we did was a patterns activity. Dots. Do you guys remember that dot activity where you like had four dots and then we added some more, where you had a star and you kept adding dots to the outside of the star and making it longer? Okay. So we decided that each time we were adding 5 on that star. That star was just, we called it a pattern. All right. But patterns, if we're adding the same number or subtracting the same number every single time, patterns can be represented linearly. So today we're going to talk about an arithmetic sequence, which is a linear pattern. Okay, it's just discrete, meaning it just has dots. So the I can statement, I wanted to do this because you guys don't have your handout for this yet. So I can, and you got to write skinny on this one because it's a lot. I can identify the common difference of an arithmetic sequence and I can write the formulas for an arithmetic sequence both recursively and explicitly. So I can identify the common difference of an arithmetic sequence, and I can write the formulas for an arithmetic sequence both recursively and explicitly. Raise your hand if you need more time. Okay, I'm going to scroll up just a little bit because I know a couple of you are writing that last statement. So the definition, we're going to add one thing to this. So the definition is a sequence of numbers where the differences between every two consecutive terms is the same. The other thing that's important is the sequence inputs are over the natural numbers. So I want to remind you what natural numbers are. Natural numbers, you know, like we have the real number system. You always say, like, what's the domain? It's anything in the real number system. Well, natural numbers were the first numbers you guys ever learned. Like when you were 3 years old and you started counting stuff. You didn't have an understanding of zero, right? When you were little, you just knew 1, 2, 3. That's what natural numbers are. Natural numbers are just whole positive numbers. Okay? 1, 2, 3, 4, 5, 6. That's it. On and on and on. No decimals, no negatives, no zero. So anytime we talk about a sequence, we know that it always has to start with, like when we input a value for a sequence, our input always has to start with 1, 2, 3, 4, and so on. Okay? Does that make sense? So we don't have to worry about evaluating it for negatives or fractions or decimals or anything like that. The first term, this is important. The first term, so the first term we call a sub 1. The first term we call a sub 1. That's the natural number 1. The second term we call what, do you think? What do you think we call the second term? Go ahead, Owen. Yeah, the second term would be a sub 2. Meaning you're going to substitute in 2 when you replace the n, right? So we're only ever using the natural numbers to evaluate our function. The other thing that we need to know is we talk about this common difference. We talk about this common difference. And in the formula, the common difference is called lowercase d. That's what the common difference is. It's called the lowercase d, okay? So I would highlight that, underline it, something. Remember, you guys have highlighters in the little buckets in front of your desks. That's why they're there. Highlight things that are important. So we have 2 types of formulas for an arithmetic sequence. The first one that we're going to talk about is the recursive formula. And the word recursive kind of sounds like reoccurring, right? It goes out, just keeps going on and on and on and on and on. So when I think about a recursive formula, the way that I remember it is that each term in the sequence depends on the one that came before it. So I can't find the 7th term unless I know the 6th term. I can't find the 10th term unless I know the 9th term, okay? A sub 1, the first term, right, in the sequence is sometimes modeled by the number k, but k is just any number. This is just any constant. It's just your starting point. A sub 1 is your starting point. It's where you start. Okay? So the recursive formula is a sub n. This means any term in my sequence, any nth term in my sequence can be found equals, I have to know the term that came before it. So if I wanted to know if I said what's a sub 20, well, that means I need to know what is 20 minus 1. That means you have to know what a sub 19 is. That's what this is saying. You have to know what the term before it is, plus the common difference. That's how we explain that, okay? So the recursive formula is only good if you're finding, like, maybe the 7th term and you know the first 4, right? Because you just add the common difference a couple of times. But if you only know 5 terms in your sequence and you need to find the 2000th term, would you want to add the common difference 1,997 times? No, that would be horrible, right? So that leads us to the explicit formula, okay? The explicit formula allows you to find any term. When we say this phrase, the nth term, it just means any term in the sequence, any term, okay? So if I wanted to find, let's say that I knew the common difference was 7, and let's say that my first term was 12, okay? Well, let's say that I wanted to find a sub 107. So I wanted the 107th term. If I wanted the 107th term, would you want to take the first term 12 and add 7 to it 106 times? That would be ridiculous, right? So the formula for explicit is you take the first term, right, a sub 1, which is 12, plus the common difference, which is 7, times the number in whatever term you're evaluating. So this would be 107 minus 1. So put this into your calculator and see what you get. Put this into your calculator and see what you get. So you're going to take 12 plus 7 parenthesis 107 minus 1. Close your parenthesis and hit equals. 742, 754. Is that what you guys got? Yeah. So A sub 107 equals 754. We like the explicit formula because it allows us to find any term in the sequence without the use of the previous term. That's why it's good. You can just find any term in the sequence without having the previous term. Okay? All right. Flip it over. Open up your little booklet. Okay. All right. So you have a sequence of stars above. So when I think about my terms, this is the first term, A sub 1. This is the second term, A sub 2. This is the third term, A sub 3. So the number tells us the position in the sequence. That's what that tells us. This is the first, this is the second, this is the third. That little number just tells you where it's located in the sequence. So when I think about A sub 1, how many stars do I have? Yeah, so A sub 1 equals 3. When I think about A sub 2, the second term, how many stars do I have? Anyone? 5. I heard someone say 5. Yeah. When I think about A sub 3, I'll write this down. The third term. So I want you to understand what that's saying. Let's see. A sub 3 has how many stars? 7. Okay. So the first question says, hey, what is the first term? Well, the first term is A sub 1. And what does it equal? It equals 3. Does that make sense? Okay. Everybody understands that? Okay. What is the common difference? Meaning, what am I adding or subtracting to get to the next term? What am I adding or subtracting to get to the next term? I'm adding 2. So my common difference, remember we represent that with the little d, is 2. So this next question is kind of getting you to think about writing a recursive formula and then turn it into explicit. So how many, if I want you to think about this, how many common differences do you add together to get the fourth term? So let's just write it out. I have A1, I have A sub 2, A sub 3, and A sub 4. We know that the first term is 3. And the second term, well, I have to add 2 to that to get 5. And then I have to add 2 more to that to get 7. And then I would have to add 2 more to that to get the fourth term. So to get the fourth term, you add, how many common differences am I adding? Say it again. 2 is the common difference. How many of the 2's? How many times am I writing plus 2, plus 2, plus 2, plus 2? 3 times. You add 3 common differences. How many common differences do you add to get the fifth term? Let's see. I have a sub 1, a sub 2, a sub 3, a sub 4, a sub 5. So I take my first term, which is 3, and then I have to add 2, add 2, add 2, and add 2. So how many common differences, are you done already? How many common differences do I add to get the fifth term? You add 4. You add 4 common differences to get the fifth term. So what do you notice? What do you think if I wanted to find the sixth term? How many common differences do you think I would add? 5. The seventh term.
6.
So the number of common differences is 1 less than the number of terms you're trying to find. Yeah. The number of common differences that you add is going to be 1 less than the number of terms. That leads us to our recursive formula. So the recursive formula is written like this. You always have to say what a sub 1 is. So right now, I'm just going to write out the formula. So we're going to say that a sub 1 equals k, some number. Remember that k is just some number. That's all that stands for. We're just writing out the formula first. And then to write the recursive formula, we say, well, any number, any term equals, what do we do? We have to know, for the recursive, we have to know the one that comes. If I wanted to find the fifth term, I need to know which term? The one that comes before it, right? So how do I show the one that comes before a sub n? Yeah, a sub n minus 1 plus the common difference. This is the recursive formula. It didn't grab the R, I don't know why. I just have to erase it and write it all again. This is our recursive formula. So we're going to write a recursive formula for our sequence. This is going to be for the sequence above. It's still going to be the recursive formula. So what is a sub 1? What is our first term? Lysandra, what was the first term in our sequence above with the stars? How many stars did I have in the first term? How many stars were in the first picture? 3. So a sub 1 equals 3. So that means that if I want to find the nth term, I have to take the term that came before it, n minus 1, plus my common difference. What is our common difference? What are we adding each time? 2. So this is the recursive formula for our stars. So what do we say about the recursive formula? The problem with that is the only way that we could find the 10th term is if we knew the one that came before it, which would be the 9th term. If we wanted to find the 100th term, we'd have to know the 99th term. That's the downfall of the recursive formula. We have to know the term number that comes before it. So let's think about building an explicit formula. Same number of stars, and we're trying to find the nth pattern. So the explicit formula, so this is the explicit formula. So a sub n equals the first term plus the common difference times the n minus 1 term. And we said that. That's why we were figuring out how many common differences we had to add. We know that we add the number of common differences that we have to add is 1 less than the number of terms we're looking for. Okay? So let's write the explicit formula for our stars sequence. So what was the first term in the stars? What was a sub 1? 3. So we start off with a sub n equals, we're replacing a sub 1 with 3 plus, what was our common difference? 2 times n minus 1. Okay. Do you think you could simplify this? Can we simplify this?
Yes, we can.
What would we do to simplify it? That 2 can't be combined because why? Why can't that 2 be combined with the 3? I love that because you have to distribute it through the parenthesis. I want to do that. I want to do exactly what Owen said. I want to see if we can simplify this and see if you recognize the type of equation that you end up with. So let's see. A sub n equals 3 plus, what is 2 times n? 2n. And what is 2 times negative 1? Negative 2. Thank you, Tim. Tim, do you see that you can combine 3 minus 2? So really, a sub n equals 2n plus 3 minus 2 is 1. This looks a lot like y equals mx plus b. Doesn't it? A sub n is a function, right? Just like f of x. And we know that f of x has the same meaning as y. So a sub n is just like y. Common difference times the term number is the same thing as your slope times the input value plus your y-intercept. So I think that linear functions were derived from sequences. Okay? All right. How many stars are in the 43rd pattern? So I need to find a sub 43. So first, I want to ask you, what formula do you want to use? What formula do you want to use? If we use the recursive formula, it's sweltering here today. If we use the recursive formula, what do we need to know for the recursive formula? We need to know go up top. What does it say about the recursive formula? Slide up. What does it say? We need to know the one before it. So if we use the recursive formula, we've got to find the 42nd term. Do we know the 42nd term? So we don't want to use the recursive formula. We want to use the explicit formula because the explicit formula lets us find any term, right? So we're going to use the explicit because it lets us find any term. That is so important. That is so important. The explicit formula lets us find any term. Okay? So we're looking at the explicit formula, which happens to be this right here. So I'm going to write it again. A sub n equals a sub 1 plus d times n minus 1. What are we doing with the n? Go ahead, Owen. Not yet, not yet. We want to have a nice equation. What do we have to do with the n? What term number are we looking for? We're looking for the 43rd term. So we're going to replace the n with a 43. And we're going to replace a sub 1 with the first term. And we're going to replace d with the common difference. We know all of that information. We know all of that, okay? So let's see. A sub 43, we're replacing the n with a 43, equals. What was the first term in the star pattern? I've already asked Lysandro. I've already heard from Owen. What was the first term in the star pattern? Ken, a sub 1 was equal to what? If you said something, I could not hear you. 3, yeah. 3 plus common difference, 8 and s, common difference. 2, is that what you're saying? 2 plus 43 minus 1. What is 43 minus 1? It's 42. So a sub 43 equals 3 plus 2 times 42. So the 43rd term equals 3 plus 84. So our 43rd term is 87. Our 43rd term is the number 87. What are your thoughts about that? Okay. I'm going to leave that up there for a second. Kylie, are you good? Okay, everybody ready? All righty. So we have 2 more examples to do. 2 more examples. All right, so I have an arithmetic sequence shown right here. The numbers in my sequence are negative 2.4. What term number is this? Say again. It's a sub 1. It's the first term. What term number is this? A sub 2. Good job. What term number is this? And the last one in our sequence is what? Do you guys see this dot, 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 dot? What does that mean? Yeah, that pattern is just going to keep going and going and going, right? We have to find the common difference. We have to find out what we're adding or subtracting each time to get to the next term. What am I adding? What am I adding? What am I adding? I'm going to write something off to the side because sometimes the common difference, especially with decimals, is really hard to see. So if you ever want to find the common difference, you can pick any term in the sequence, and from it, you're going to subtract the term that comes before it. Any term in the sequence, and take that term and subtract the one that comes before it. And that'll give you the common difference. So we know that our common difference is, well, if I use the fourth term, 8.4, and I subtract the third term, 4.3, what do I get? Oh, 4.8. Thank you so much, sir. So 8.4 minus 4.8. What do I get, Lissandro? Open your eyes, pick up your calculator, crunch it out. $3.6. So we know what our common difference is, and we know what our first term is. We know that a sub 1 equals negative 2.4. Both of those are so important that I think that's what pretty much the first three questions are asking you about. So the first question says, what is the fifth term? We can't find the fifth term unless we know the common difference. So we are adding, Lissandro said 3.6 each time. So to find the fifth term, a sub 5, we have to take the fourth term, which is 8.4, and we have to add 3.6 to that. So what is the fifth term? $12. A sub 5 equals 12. What did we say the common difference was? D equals 3.6. So we have to write the recursive formula. We're going to write the recursive formula. So who feels like they can do that? So for the recursive formula, you always start off by stating the first term. So what is the first term? What was the first term in that sequence? Avery, what is the first term in that sequence? Negative 2.4. I know you guys know what's going on. You're just being quiet. Okay, so that's the first part. You have to say that. And then what does it start off with? It says a sub n, any number term equals the term that came before it. We show that by saying n minus 1, a to the n minus 1. We have to talk about the term that comes before it. And then what are we adding to it? 3.6. Good job. This is the recursive formula. You must include a sub 1 every single time. Otherwise, you don't know where to start, right? You don't have a starting point. So you have to say what the starting term is. You have to include that. Okay. Now we're going to write the explicit formula for that sequence above. So the explicit formula starts off with a sub n equals, and for this one, we just need the first term. Whoops. What is our first term? Hang on, I got crazy going down. What is our first term, Owen? Negative 2.4 plus what? 3.6 times the quantity of, if I want the seventh term, I multiply how many common differences? How many common differences am I adding? If I want the seventh term, how many common differences am I adding together? 6. So if n was 7, I would need the sixth term, which is n minus 1. Okay, n minus 1. And we're going to leave it just like that. We're not going to turn it into something that looks like a linear function, y equals mx plus b. We're just going to leave it like that. So This last question in this about this sequence says, what is the 32nd term? What is the 32nd term? Kylie, what equation form are we going to use? What formula setup do we have to use if we want a specific term number? Are we going to use the recursive or the explicit? If I need to know a specific number, don't look at her, look at me. Do I know the term that came before the 32nd term? No. So that means I don't want to use the recursive. I want to use the explicit. I'm going to keep doing that until we believe that. So we need to use the explicit formula. And that's cool because we just wrote it. We just wrote it. Okay. So Victoria, if I want to find the 32nd term, what am I letting n equal in my explicit formula? I'm going to replace my n with what? So let me say it again. If I want to find the 32nd term, I'm going to replace my n right here with a what? With 32. Exactly. That's exactly what I'm going to do. Because remember that all that subletter does, or that subnumber, is it just tells you what the term number is. So I'm going to write a sub 32 equals, and then I'm just going to finish out this equation. Negative 2.4 plus 3.6 times, what is in? 32 minus 1. Well, what is 32 minus 1? It's 31. So I have negative 2.4 plus 3.6 times 31. You can plug all of that into your calculator, and I want you to do that. I want you to plug all of that into your calculator. Negative 2.4 plus 3.6 parenthesis 31 close parenthesis. So what is our 32nd term? 109.2. Okay, so I'm going to write a note off to the side again, because this will be the second time I've written it. It's super important. When you want any, when you want, dang it, when you want any term, I need new batteries. When you want any term, use the what formula? The explicit formula. Use the explicit formula. I'm going to put another note here. When you want the next term, use the recursive. Recursive tells you the next term because you got to know the one that comes before it. Explicit tells you any term. That's why we like it, okay? Recursive requires that you know the one that comes before it. So if I want the next term, I can use the recursive, so I know the one that comes before it. But if I don't know the one that comes before it, I have to use the explicit. Okay? Does that make sense? Avery, if I know the fifth term and I want the sixth term, what formula are you going to use? Let me say, I'm going to write it down. If I know that the fifth term, a sub 5 equals 12, and I want to know the sixth term, what formula are you going to use? You're going to use the recursive because you know the term that comes before it. Okay? If I know the first term is 27, and I know that the common difference is 8, and I want to know what A 107 is, what formula am I going to use? Explicit, because I don't want to add 8 to 27 106 times. That's crazy, right? Do you want to just keep doing plus 8, plus 8, plus 8, plus 8, plus 8 in your calculator? No, that's crazy. So you're going to use the explicit. Okay? All right. We have one more example. One more example. So we have a sequence given to us, and this is the recursive formula. This is the recursive. How do I know that without it saying that? I know it's recursive because the first term is given. I know it's recursive because you have to give the first term. So the first term is given. That's how I know it's recursive. Okay? So it's asking you to find the first 6 terms of your sequence. The first 6 terms. So we need to find a sub 1. We need to find a sub 2. We need to find a sub 3. We need to find a sub 4, a sub 5, and a sub 6. This is what you're going to be given. You're going to be given something like this. And it's going to say, hey, find the first 6 or 7 terms. So what is the first term? First term is 12. What is the common difference? What are you adding or subtracting each time? 4. Yeah. So to find the next term, what do? Add 4 to it. So the second term is, to find the next term, what do? Add 4 to the one before it. 16 plus 4 is 20. To find the next term, you have to add 4 to the one that came before it. What's 20 plus 4? To find the next term, add 4 more. So the fifth term is, I didn't hear anybody, 28. To find the sixth term, I have to add 4 more. 28 plus 4 is, this is how you use the recursive formula. You just keep adding the term, the one that came before it, you add the common difference to, right? That's recursive. You got to know what came before, okay? Does that make sense? Okay.